Hi everyone, this is Dr. Hira. So in this lecture, we are talking about the preparation of carboxylic acids. So how we can synthesize the carboxylic acids by the different starting material. So we will discuss some of the industrial preparation methods and some of the other major methods by which the carboxylic acid are usually prepared. There are a number of ways, but I have only mentioned the most significant and the major methods for the preparation of the carboxylic acids. So the one is the oxidation of primary alcohol. The second is the oxidation of aldehyde, which we already have uh, discussed in detail in the previous lecture, which is a title as the oxidation of aldehyde. So you can check out that lecture. So I will not going to explain that at the moment. So because that we already have discussed in the previous lecture. The third method is by the carbonation of the Grignard reagent, in which the Grignard reagent is reacted with the carbon dioxide. And additionally, we are going to discuss the industrial methods too. The first thing is the first method which we are going to talk about is the preparation of the carboxylic acid by the carbonation of the Grignard reagent. So the carbonation of a Grignard reagent is a convenient way to convert an alkyl or aryl halide to a carboxylic acid, and from where that alkyl side is coming, that is coming from that Grignard reagent, right? So if we react it with the carbon dioxide, so we can eventually get our carboxylic acid. So we will see what is the mechanism of this one. So in this, basically, we are reacting the Grignard reagent with carbon dioxide, and there will be the intermediate, which will be the magnesium salt of a carboxylic acid. And on the protonation with the aqueous acid, it will give you the carboxylic acid as a final product. So here you can see this is a Lewis structure of the carbon dioxide. And this is our Grignard reagent, which is a magnesium bromide with an alkyl chain, right? So when there is the rearrangement of this carbonyl oxygen, or you can say this doubly bonded oxygen, so that could be with any of that oxygen atom here. So if it is taking back its these pi electrons, so making this carbon as an electrophile. So there, this will attack on this side, right? And there will be the magnesium carboxylate, right? And that is a salt of magnesium, magnesium salt of carboxylic acid, because here this is only the hydrogen is missing still. So now when we'll go for its aqueous protonation of that magnesium salt, so then eventually we will get the OH, because there is the hydration of that one, so that is coming from here, and the magnesium bromide will be releasing from there. So the rest is the different byproducts we are getting here, right? So that is the reaction mechanism of the Grignard reagent and the carbon dioxide, and how we can prepare the basic alkyl chain. And this is a major alkyl chain which is coming from this Grignard reagent. When we carbonate that magnesium or Grignard reagent, so we get this product, and on the protonation that will go for the final product. This is a cyclopentane carboxylic acid. Now we'll see another method, that is the by oxidation of primary alcohol. So the oxidation of primary alcohol gives an aldehyde or a carboxylic acid. That depends that if we go for the further treatment of that aldehyde to the hydrogenation, right? So the other thing is the depending on experimental condition. So the secondary alcohols oxidize only for two ketones, so they are not giving you the carboxylic acid. Tertiary alcohols, because they are supersaturated already with the alkyl groups, so they don't oxidize. So here, what is happening, what is overall general reaction steps for the oxidation of primary alcohol to the carboxylic acid, and then later I will talk about its oxidation mechanism in detail. So we are treating the primary alcohol. So this oxygen in brackets is mentioning that we are going through the oxidation step. So that generate the an aldehyde, which on again this the second oxidation step, so that will go for the carboxylic acid. Now we'll see that what are the reaction condition and how we will convert the primary alcohol into the aldehyde and then eventually to the carboxylic acid. So this is the process in which if we are interested, we can stop the reaction at the a stage where we will get the aldehyde, and then uh, if we are not interested for the carboxylic acid, but otherwise if we'll keep on cheating that, so we can finally get our carboxylic acid. But of course we are talking about the preparation of the carboxylic acid, so we will proceed that reaction till we will get the carboxylic acid, which is our objective product. So here, this is the butane 1O. This is the butanol or starting material. And what is the oxidizing agent we are using here? So that is basically the chromic acid. I have discussed that in detail, that how that chromic acid is generating. So we can use the chromium oxide, we can use the potassium chromate for preparation of the chromic acid. So you can go to that lecture for the further details. So here the chromic acid, which is the CrO4H2, right? So this is the chromic acid in which the chromium is in the 6 oxidation state. Now this is the primary alcohol. So what is happening here, that the chromic acid is basically specific for attacking on the hydroxyl side of a molecule. So that's why this is very much good to attack on the primary alcohol. So what is happening, that this chromic acid hydroxyl will take up that proton from here, eliminating the water molecule, and then there will be the attack of this nucleophilic oxygen of the on the chromium, and then there will be this intermediate which will be formed, and this is called the chromate ester in general, and its systematic name is butyl hydrogen chromate, but commonly it's known as the chromate ester. So the first step is basically the reversible and the fast step, right? Because they are just quickly this is picking up that proton, and there's attachment, and this is a chromate ester which is forming, right? Now in first step, you can notice that there is no change in the oxidation state of the chromium, right? So this is just an attachment and the removal of the water molecule here. So I'm writing this the hydronium here because we are using the acidic condition, as I have previously mentioned this, that we are using the reaction condition that you will use water, we will use acetone as a solvent, we will use the concentrated acid for converting this chromium oxide or potassium chromate into the chromium acid, right? So this chromic acid then available in the attachment, and this is making the chromate ester here. Now we know in our reaction system there is a water molecule, and this water molecule is behaving as a base here. So if you just look at this one, so this is the internal rearrangement of that molecule, right? So this chromic acid will remove from here, and there will be the hydronium ion, which is which will be as a side product, which is available for the removal of the water and the acidic medium. So here, that after this rearrangement, that is converting into the aldehyde, right? So we can stop the reaction here if we are not further treating this aldehyde with the chromic acid, but of course we are going for the carboxylic acid preparation, so we will treat that aldehyde again for the further oxidation to the carboxylic acid. Now the interesting thing is this one, as I told you, that this chromic acid is specific, and that can attack on the hydroxyl side, not on the carbonyl um, oxygen. So that's why the first step is that we have to convert this aldehyde into its hydrated form. So this hydrated step is very much important. So uh, for this hydration, we are treating this with the water molecule, right? And there is the conversion of this aldehyde into the 2-dihydroxyl molecule, which is the diol one, right? Initially, this there will be the back of this pi electron to the oxygen, and this is getting the negative charge. So that will abstract the proton from here, and that get hydrated. Now this carbon, which is becoming the electrophilic, so there will be the attack of this nucleophilic side of the water molecule, which is hydroxyl one. So here there will be the further attachment of this hydroxyl group, right? So this is the butane 1,1 diol. Now we are treating it with the chromic acid. So with the treatment of the chromic acid, this hydroxyl of the chromic acid will combine with and abstract that proton, and that will eliminate as a water molecule. Now here you can see that from this step, this chromic acid has converted, this chromium has converted from this +6 to the +4 form. What does it mean? That this chromium is basically reducing, right? So this has accepted 2 electrons further. Now here, if you just look, go to the next step, is that again there is the chromate ester which has formed, but now chromium is in the oxidation state 4, which will further convert into the chromium 3. So here again that water molecule attack on it, and this will eliminate here, and we will get this as a product. So this bond is breaking, and there will be the electrons will shift, and there will be the carbon and the double bonded oxygen here, right? There will be the hydroxyl which will attach to that way, and this proton has eliminated from that side, right? So again, the question is this, that we have this hydroxyl, right? And the one hydroxyl have been abstracted from there, right? So again, there will be the OH, which has combined to this one, and this is a doubly bonded to this one. Now, another important thing, which is there may be the problem, I have to correct that one. So basically, this proton is not there, so I have to cross that one. This is the typo's mistake here, right? So this is not there. I have to cross that one. So initially, when this is combining this side, this is abstracting, water molecule is eliminating from there, and this oxygen is combining with this chromium O negative and doubly bonded O, and then there is this initial hydrogen here, and now when the carbon one bond is breaking with the hydrogen, and there is a double bonding with the oxygen and the carbon, right? And that hydrogen will eliminate from this side, right? So that will be captured by this oxygen, and there here this will be the hydrated form of this one. So here this hydroxyl is attached to that side, right? And here this is our carboxylic acid. Now this chromium 3 do exist in a system, either in that way or in the system which we have the water in a medium, so that will easily go for the more stable salt, which is a chromium hydroxide. This is a CrOH3, and we have the hydrogen, we have the water molecule here, so they are combining and they are converting it into the more stable form, the chromium hydroxide, which is somehow the greenish N color, right? And finally, we got our carboxylic acid as a product. So that was the method of the preparation for carboxylic acid by using the primary alcohol. But primary alcohol will be converted into the carboxylic acid by the use of the catalyst, which is the chromic acid, and we will use acetone and water as a medium, reaction medium for the synthesis of these carboxylic acid. There is a key point which you should know, that the hydration step, which I have told you is a second step after the formation of the aldehyde, is this one, that the chromic acid is specific to attack on this hydroxylide, not on the carbonyl oxygen. The next is the industrial synthesis of acetic acid. There are a number of ways by which the acetic acid is preparing, because acetic acid is used in many of the industrial processes for the production of substrates, and it is often used as a chemical reagent for the production of the number of chemical compounds. And this is also one of the leading manufacturing industry in the US, that this is the product which is highly manufactured. On the top, this is manufacturing in the US, because this is usable in a lot of industries, which include the paints, medicines, vinegar, and for example, the food industry. So there is a lot of products which we are preparing by taking up the acetic acid as a feedstock. So the first method is the acetylene, and it's hydrolysis in the acidic medium, and there's a mercuric sulfate which we are using. So the acetylene can be converted into the acetaldehyde, which is on further oxidation with the cobalt, it's converted into the acetic acid. So that was the first synthetic method for the preparation of the acetic acid by using the acetylene one. Another important process, industrial process, is the Wacker process, which is on the name of the scientist, chemist who developed that method, is by utilizing the transition metal catalyst for the oxidation of alkenes. So when we treat the alkenes, or this is the ethene, right? So when we treat ethylene with the oxygen, so this is converted into the acetic acid. So basically, Wacker process is for the preparation of the carboxylic acid. So this, the first step is when it is converting into the aldehyde, and on the further treatment, that will convert into the carboxylic acid. So the major uses of the acetic acid are, they are the key four uses, industrial uses of the acetic acid. That is widely used in the vinegar. So you know, the vinegar is available in a kitchen, in a household use, for the pickling and for other dish, and for treating the other stuff or cuisines to the um, modification or the preparation of any of our desired dishes. Other one is the medicine. Acetic acid possesses excellent antibacterial properties, and it's used as an antiseptic when used as a 1% dilution. It can be used as an alternative product to prevent infection and kill bacteria, and that's why the common remedy is in our household is that when you take 1 tablespoon in a water medium and you soak your vegetable and fruit in it, so they are all bacterial free. They're claimed to be bacterial free because this is having the antibacterial properties. It does also have the widely use in the photography and the film. So the first thing came out which has replaced the nitrogen film was the cellulose acetate, and this is using this is prepared by the acetic acid, which firstly converted into the acetic anhydride, and then by reacting with the cellulose, it is converted into the cellulose acetate, which is used in the film and the photography. The other one is adhesive and paints, vinyl acetate, which is again prepared from the acetic acid, is a monomer which is actually used in the primary product that uh, for example, for the vinyl polymers which we are using in our paints and the adhesives one. So these are some common and the major industrial application of the acetic acid. Now the next is the task: complete the following reaction you have to draw the mechanism of the Pauling reaction. So this is again uh, an alcohol with which we are treating in the same condition that we are here using potassium chromate. So the hint is this, that when we are treating the potassium chromate with the sulfuric acid, and you can go for that lecture of the oxidation of aldehyde, so you will be able to see that one. So again, there is the chromic acid which is preparing, and the reaction will be with the chromic acid, and eventually we will get the carboxylic acid. So you have to submit that task on a Moodle, and if you have a query, you can ask that one. That's all about for this lecture. Thank you. Have a good day.